Hi everyone, this is Sean Ismail with the Cloud Ranger, and you are viewing the Microsoft Azure training. Today is the part 8 of Azure Virtual Machines, and we're going to talk about something very important. That's the VM availability sets and auto-scaling in Microsoft Azure. Let's get started. The three things we're going to talk about today is the Azure availability sets. We're going to talk about scaling Azure VMs up and down, and auto-scaling, which is a scaling in and out. I will explain what scaling up and down and scaling in and out is and the differences between these two. What I wanted to let you know is that this is what makes cloud. I mean, one of the selling features or important features of a cloud is having the elasticity where you can add and remove resources at a moment's notice based on your requirements. And Azure availability sets actually I mean, the auto scaling and scaling in general is built on this availability sets. So that's what we're going to talk about today. So let's get started with the Azure availability sets. What we know about Azure Virtual Machines is that they are similar to your on-premise infrastructure, where you have your underlying virtualization hosts, physical hosts, and you have multiple virtual machines that sit on those physical hosts. This is no different from what you have in your environment today on premises. In cloud, it's similarly, but it's a large scale, and there is a spanning of data centers from regions. There's connected data centers throughout the world. A lot of your organizations, even on-premise, could have a similar sort of not in such a large scale, but similar implementation where you have a data center connected to another data center and you have virtualization set up in such a way over fiber connections that if you want, you can move one VM from one location to another for disaster recovery or high availability scenarios. And that's what Microsoft data centers do as well, but in a much, much larger scale. So having said that, there are failures that can happen anytime we are talking about physical hardware. And there are two types of failures that can happen in Microsoft Azure. One is physical, and the one is not physical. The physical failure is the one where the underlying host might go through some sort of a hardware failure, and your virtual machine resides on that host, and you might have an issue with the virtual machine. The rack you are in or your server is located in the data center might lose power. So this is the physical failure that can happen with your virtual machine, with the hardware, and it can affect your virtual machines and services. The other thing that can happen is a failure of your virtual machines due to host updates. So as you know, your virtualization host on premises has Hyper-V or VMware. In Azure, you have Hyper-V, and what happens is that this Hyper-V itself might require patching. It might require hardware upgrade, like firmware upgrade, and things like that. And due to these updates, if you have a virtual machine on there, if there's a restart that's required, then there might be an issue with the availability of your virtual machine. So Microsoft does not do the patching for your virtual machine. I just wanted to add that in there. Your virtual machine is patched by you, but the underlying host patching is done by Microsoft. That's what I mean. Now, if you are in PaaS, not IaaS, infrastructure as a service, but platform as a service, then Microsoft actually sort of patches your virtual machine as well. So what I want to tell you over here is that to mitigate these two issues, what Microsoft has provided is something called as an availability set. What Microsoft basically says is do not have one virtual machine. Always have at least two virtual machines with similar role in same tier of your application. And what will happen is that Microsoft will ensure if one virtual machine is affected, the other one is still up and running. So end of the day, you have your service. So I'll show you a diagram in a bit and I'll explain how that works. But some design considerations is that if you take these two virtual machines and put them in one high availability set, you have to make sure they're in the same cloud service. So you have to be in the same cloud service to have a high availability set to put virtual machines in there. How many virtual machines can you put in an availability set? Well, there's no specific limit on that. I mean, depending on, what's your requirements are, and I'm going to go through a little bit of more on design on the limitations. But you could put two at least of a minimum in a high availability set to make sure that there's some sort of a failover. And the other thing you have to know, like I mentioned, is that design-wise, you always want to have these virtual machines in the same high availability set, perform the same similar workloads, or be in the same application tier. And as usual with most thing Hyper-V, and most thing Azure, you have to remember that you can have this feature, you can have this feature or you can add an high availability set while you are creating the VM or when the VM is already created. This is like most Azure stuff. So let's actually go to a diagram real quick so I can explain this a little better. So these are three availability sets, and what I'm showing over here is a basic three-tier application where you have a web front end and you have app server, which accesses database servers. So what Microsoft recommends is that you have an availability set where there is at least similar services or similar roles or same roles actually in the same tier which are put in the availability set. So the web front ends will go in the same availability set, the apps will go in the same availability set, the database servers would go in the same availability set, and of course this availability set, these virtual machines need to be in the same cloud service. So this is your WFE, this is your app, this is your DB. These are the cloud services, three cloud services hosting these three availability sets where they function with similar roles. Okay. Now, if one of them goes down for whatever reason, either a physical, issue or a Microsoft is doing one of the updates, Microsoft ensures the other one is left alone as long as they're in the same availability set. And let's get into details of that. So in availability sets, there are two important things, both for your exam and production. You need to remember these terms. One is a fault domain and another one is an update domain. So, after reading a lot of material on this, all I can tell you about fault domains is that Microsoft says if you have at least two servers in a high availability set, which is similar to what we had over here, at least two servers in high availability set, Microsoft ensures that they are in separate physical hosts in different racks. So the way this works is that, as you know, in a data center, you will have racks of server, right? So when you put two servers in an availability set, Microsoft is telling you, not only I'm going to make sure that these two virtual machines are not on the same host, they're also not going to be in the same rack. So if for some reason the rack loses power or the server has some hardware fault, we will ensure that you are on a different rack, on a different host, physical host, where where if it affects one, the other one is left alone. Okay, and then you have the update domains, and this one, in basic, simple terms, means that if you have at least 5 servers in a high availability set, Microsoft ensures that these are updated at separate times. Okay, so depending on your appetite, on how much you can have of a downtime, um, these are the minimums, or these are sort of the numbers, magic numbers Microsoft works with when there are availability sets. Okay, do you need to put 5 servers? Maybe not. Maybe you can get away with 2, because even if you're just having 2 servers, they will be ensured that the update domains are separate. Okay, one will be update domain 0 and the one will be update domain 1, for example. And um, do not forget that this does not come for free, right? I mean, if you are spending one virtual machine for a web front-end server, and you actually have another, virtual machine who's running the web front-end, Microsoft still is going to charge you for those two virtual machines. So it's not like one virtual machine is there and another one Microsoft is throwing away for free. It's just that Microsoft is saying if you put at least two virtual machines in an availability set, I'll make sure that there is no physical failure that will affect your virtual machines. And while I'm updating my hosts, if you have at least 2, you'll ensure that one of them is up and not all of them are updated at the same time. Okay, so let's look at this diagram over here, and I actually have 6 here for a specific reason. So if you have fault domain, when you create the first virtual machine and add it to the high availability set, it will be 0. When you add the second one, it will be 1. So fault domain ensures that at least these 2 are going to be on 2 separate racks in 2 separate physical servers. Now, if you have the third one, just because you can only have 2 servers for the fault domain, the third one might fall into fault domain 0, which means that VM1 and VM3 might end up on the same rack and same hardware. So as far as fault domain is concerned, after 2, it does not make any sense, because Microsoft ensures only up to 2 for fault domain or 2 racks. So even if you have 6 virtual machines, as far as the physical failure, hardware failure goes, Microsoft tells that, hey, I might put the other ones on the same rack. I'm just ensuring that two of them are separately done. So if you actually had uh, six of them, three of them would be in the same rack maybe, and the other three would be in another. So three of them might go down at the same time if there's a power failure, and the other three will be up. I'm not saying that they're going to be in the same rack, but I mean in the rack, but Microsoft ensures that at least that's how it happens, and there are possibilities that it might. So you could get away with two when it comes to fault domains. Now, with update domains, there are 5 servers. So if you have 1, 2, 3, 4, 5, you can see up to VM5, they're all unique. Means these 5 servers, the physical servers that are hosting them are not going to be updated at the same time. Microsoft ensures that up to 5 of your virtual machines, they'll be done separately. This is just updates. This is not hardware failure. This is the update domain. Now, what happens when you add the 6th one? Well, it ensures up to the first 5. With the 6th one, it might go back to 0. So what will happen is that if updates are going on, these two VMs might go down at the same time because they might end up in the same hardware. The other ones will be done at a different time, right? So that's what basically availability sets is and what fault domains and updates domains will do for you. And as usual, you can do this from both UI and you can do this from PowerShell as well. The example over here I'm trying to show you is the set Azure availability set. This is the commandlet that's used, and you got to give a name of this. Availability sets, and that's about it. So the name for my all these virtual machines will be Ranger webset. So as long as you're making a virtual machine and putting them in the Ranger webset high availability set, they all will be part of the same high availability set. And as you can look at this example by now, you can see that this is probably happening on a virtual machine that's already created. Of course, if you add this as part of the VM config while creating the virtual machine, it will be made as well. Okay, so these are the things that I have to show you. Now let's jump on my client machine and I'm going to show you this in real life and show you at what location what is. Okay, we are in our in my my client computer where I'm connected to my subscription. As you can see, what I've done in the back end is actually create 6 virtual machines. They're basic virtual machines with not too much resources, but I just wanted to show you what they're doing. Looking at this DNS name by now, you should be very comfortable by looking at this, what it means. What Ranger Web, all of them having the Ranger Web, it means that they are all part of the same cloud. And let's go to the cloud service here, go to the C-Ranger Web. I want to show you the instances over here. As you can see that all these virtual machines are part of this cloud service. Okay. Now, the other thing I want to show you over here is that if you want to go in one of these virtual machines and go to configure here, you can see that I have put them in the same availability set. So while I was creating them, I put them in the same availability set, and you can actually see from each of these virtual machines what availability set they are in and which other virtual machines are already part of it. Okay, and the way you put a virtual machine as part of an availability set while creating it is this way. Let's go create a new. I would create a basic virtual machine. C-Ranger 007. Just keep it standard A2. What I'm doing over here is that, like I mentioned, they all have to be part of the same cloud service. So I already have an existing cloud service called C-Ranger Web. I would put it over there. Forget the storage account for now. You can see that there's something called here as availability set that we have ignored all this time. What this does is that since I created the very first one in, C-Ranger AV set, there is one already over here. I could create a new one, and as soon as I create a new availability set, I could give a name over here, and I'd click next, 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 and this is how you would create a virtual machine in a availability set for the first time. But since I already have an availability set, all I'm going to do is I'm going to put it in that same availability set, click on next, and click OK, and that's it. That's all there is to put a virtual machine in an availability set. And when it will be done, when you go inside and you look at configure here, you'll see CRanger 007 show up over here. It will show it's part of the same availability set. The other way to see this, obviously, like I mentioned, is from the cloud service. Since they're all part of the same cloud service, you can go to the instances. But there is something in the cloud services where I want to show you right now here. Okay, look at that update domain and default domain. So looking at this, you can see the fault domain is like two of them are unique. And that means that there are two virtual machines which are confirmed to be on two separate fault domains, means two separate physical hardware and in the two separate racks. With update domains, as you can see, the first six anyways, 0, 1, 2, 3, 4, and 0, 1, 2, 3, 4 is total 5. So 5 of them are in separate update domains, and this one is, of course, returned back to this same update domain. So chances are when these virtual machines hosts are updated, CRanger 001 and CRanger 006 might be on the same host and they might be updated at the same time. So that's all that there is to availability set, but it happens to be one of the most important ones that you will decide on while you are doing any production work. And the reason behind that is that it's very simple. You want to make sure that your virtual machines are highly available and they want to be together. Now, some of you might have some more technical questions, and is that, hey, Sean, what happens to like the on-premise clustering and high availability systems between SQLs and this and all that? Well, the high availability over here is based on the fact that you are going to have based on the fact that you are going to have your own mechanisms to actually deal with the high availability. Microsoft just ensures that you have these two virtual machines isolated isolated in a same set to ensure the services are there. So for example, if you have two web servers, going back to our example here, what Microsoft is not going to do is do the, load balancing for you. You have to make sure that you put them in a load balancing set. You have to make sure that your DNS is set up properly. So when your users hit this web application or this website, they're okay with one of these virtual machines going down. Um, like, will the same happen if these two database servers are together? These two SQL 2014 servers, for example. You know what? Perhaps not. All Microsoft is saying that if you have SQL running on DB1 and SQL running on DB2, I'll make sure that these two are not going to, go down all at the same time when I'm doing an update or there's a hardware failure. But you need to make sure that you have the logic behind to make sure that your app servers are aware of how these guys are load balanced or made highly available. And in SQL, like you could do this with log shipping, you could do this with high availability, like always on, and those awesome things. But Microsoft is not going to do that for you. You still have to do the application layer stuff by yourself. This is just high availability for your virtual machines. It's not for your servers. And you know what? This is almost similar to your on-premises stuff. You have to make sure that you do all the application level configurations, okay? So anyways, that's all that I do have for high availability set. Now we're going to move into the next thing, which is scaling. Okay, so let's talk about scaling virtual machines up and down and in and out and what are the differences between them. So when you say that you're scaling up and down on a virtual machine, up means you are taking the virtual machines, for example, it has 4 gigs of memory, just for example. When you're going scaling up, you basically mean that you go to the same virtual machine and you go and say that, hey, from 4, my business kind of sort of changed. I'm going to make this now 8 gigs of memory or 16. Okay, so you remember this whole dynamic memory thing on premises? This is sort of that thing that you're going up and down on your resources. Sometimes you need more memory, so you go and add more memory to it. And on a virtual machine, this is the best part, is that you can do all this virtually. It's not a physical hardware that you have to take things in and out and put that, right? So when you add or remove resources to an existing object like a virtual machine, you basically go or you mean that you're going up or down. This could be hard drives, this could be memory, this could be CPU, this could be whatever. The way in and out works is that rather than going to the same virtual machine and adding more memory, you're saying that, hey, I have one web front-end server. I'm not going to add more memory, more RAM, more CPU. But what I'm going to do is that rather than having one web app front-end server, I'll have two web front-end servers or three. And if when it's busy in the mornings, what I'm going to do is I'm going to have 10 web servers. And end of the day, at night, when nobody's there, I'll come back to, for example, two or three. So rather than adding and removing resources to a single virtual machine, you're actually adding and removing virtual machines itself. Since in Azure, it's easier to spin up virtual machines and turn them off and turn them on, Microsoft is sort of using the best practices where they're not going and doing up and down of resources on the same virtual machine, but they're adding more virtual machines and removing that because this is what cloud is good at. So scaling in and out is the preferred method than scaling up and down in Azure environment. Okay, but nevertheless, if it's a consistent thing, if it's an application requirement all of a sudden to have more memory on the VM it's running on, you still have the option for up and down. And as we mentioned before, that virtual machines have different instance sizes, pre-built images, for example, of all these virtual machines that you deploy things on or you provision your virtual machines off. You can change the instance size. And let's go to my machine over here, and I'll show you that real quick. If I go to the virtual machine here, crange001, for example, and I go to configure, you can see that my current virtual machine size is on an A2, which is using 2 cores and 3.5 gigs. And for some example, like I mentioned, for whatever reason you say that that's not working for me anymore, I want to bump the resources on this specific virtual machine, you can do so. You click on save, and it's actually giving you the warning that your virtual machine might be restarted, and which we totally understand. So planning wise, it's important that you remember that. But you click on OK, and basically your A2 virtual machine with 2 cores and 3.5 gigs of memory will be bumped up to 4 cores and 7 gigs of memory, and which is pretty awesome. But there's things you have to remember while you do that, that this instance site supports that these virtual machines have same number of data disks. And I've showed you that website many times where you can actually go and look at all the details from MSDN on these instance sizes and have the number of data disks. You have to make sure that this up and down can only be done if they have the same number of data disks. So there might be an instance size that will not be supported. So you can only go up and down within the parameters of what it can do. So let's go to crange002. As you can see, you can go from A2 and do all of this, but Azure actually has way more instances than this, and there are other series of virtual machines that you may not be able to go to because they might not have the same kind of data disk or same numbers of data disks that are supported. So the only thing you have to remember here for up and down is to make sure that data disks do match. So that's planning wise you have to remember. And while we did that from the management portal, of course, set Azure VM size and instance size. You can specify the instance size you want to go to. So over here in this example, I'm going from whatever instance size it was to A8, for example. This is the commandlet you set as your VM size. Of course, you would filter this to get Azure VM and the cloud service and the VM name. So you want to capture the VM object and then pass this in there. But this is what you need to remember. And of course, you can do this from the management portal as well. So there's not a whole lot to talk about this, but this is how you change the instance size once you already have a pre-existing one. Of course, if you have planned everything well, you may not have to do this change of instance sizes. I mean, not even at all, rather than often, that you'll probably will not need to do this at all if everything's planned properly, okay? But that's what scaling VMs up and down is all about. But the most important one we are kind of concerned with in this session is auto-scaling. And auto-scaling with Azure is not about up and down, it's about in and out, which is adding more virtual machines to a resource and removing more. And I will tell you how this ties up to a high availability set. So auto scaling basically means that you are giving Azure the capability of automatically starting and stopping the virtual machines. What Azure will not do for you is Azure is not going to create a virtual machine for you. you'll have, for example, 10 web front-end servers, and you'll only be using, for example, 2, but you'll give instructions to Azure that, hey, in so and so time, like for example, morning 9 o'clock or end of the day, 5 o'clock, 6 o'clock, or 10 p.m., I am giving you the capability of going and turning on these virtual machines and turning off these virtual machines all by yourself. Azure is going to do that on your behalf, so you don't have to babysit this based on obviously some configuration or scaling rules that we will get into in a bit. Now, scalability here is out and in or in and out rather than up and down, okay? So auto scaling is only in and out. Azure will not go add more memory to your virtual machines or change your instance size, okay? And I mentioned that many, many times because it's important. All it will do is start your virtual machines and turn them off. So the whole up and down and in and out needs to be absolutely clear at this point. And the VMs must be of the same size and the same availability set. Okay, so if you are using A3 for your one instance, you have to make sure all those virtual machines are going to be all A3. So it's easier for Azure to calculate what's going on at any certain specific time. And there is a reason for that. And how is this all controlled? Well, they're all part of one availability set, means also all part of one cloud service. So what Microsoft is saying that have all your this 10 A3 web front ends in one availability set and in one cloud service, and you give me some configuration rules, and I will turn them off and on automatically for you on your behalf, given on the parameters that you provide. Which is my next point, which is scaling is triggered based on configuration rules and scaled rules. So you have to provide the rules for Azure to actually abide by. So you can tell them, for example, business hours. Hey, Azure, you know what? Morning 9 o'clock, I want you to go and sort of start all 10 front-end services. Or, there is some CPU utilization. If you find out that two of my virtual machines that are providing the front-end services actually have more than 50% of CPU utilization, go ahead and spin another 5, for example, or all of them. So you can understand automatically that the load went up. So since the load went up, I want more servers to be in the high availability set and in the load balancing, for example, and make sure that my users are not impacted. And it could be metrics like memory usage as well, queues, and a lot of other configuration rules that you can instruct Azure to work on and calculate before it goes and turns on virtual machines or turn off virtual machines. Okay, and I'm going to show you this how to do that from the portal. The thing that you have to remember with this auto scaling is that it could take Azure up to an hour to do this. Why does Azure do that? Well, Azure is telling you that, hey, I'm going to start these virtual machines up and down for you. I do not want to go into a situation where you have all of a sudden a spike in your CPU for like about 2 minutes, and just because your CPU on this virtual machine was spiked up to 2 minutes, I'm going to spin up another 10 virtual machines only to find out 5 minutes or 2 minutes later that they are all gone back to normal. So Azure does not want to get into a point where it's powering up and powering down your virtual machines crazy, because as you know, your CPU can go up and down depending on, a lot of things. Azure wants to have some sort of consistency. So what Azure does, the entire process to calculate, to make sure there's a consistency that, yeah, you are hitting 50% of your CPU consistently for the last 15 minutes, for example, and calculate based on that, the result would be as you're going and spinning this whole 5 or 6 other virtual machines, this entire thing can take up to an hour. Okay, so this is good for macro scaling. Macro scaling means that like I have users coming in and there is a consistent amount of load, so I think that I need to go and alleviate some of these roles or mitigate the whole performance issues by spinning few more virtual machines. I don't want it to go crazy to a point that every time the CPU hits 50% for whatever reason, Azure goes crazy and brings up that new virtual machine and turns them down. So they're good for macro scaling. this is good for when you have a consistent load that is very well measurable. And this is something you have to remember in production because if you have all of a sudden a load where bam, you have like 9 o'clock, like thousands of users coming in, and within 2 minutes they're going to take you down. Well, that's not how it will work. You will have to give it. I mean, you'll have to plan this a little bit more better than make it go spike up in 2 minutes and spin 10 virtual machines or 100 virtual machines within 2 minutes. That does not happen. So take that an hour. I mean, plan that carefully when you are talking about auto scaling and letting Azure do it for you. Okay, and you know what? This actually works for 95% of people. This auto scaling will be perfectly fine based on what you do. And for that 5 specific percent of people, maybe you need to plan this out differently. Or if you have the load where you think that within 2 minutes you're going to be impacted so high, maybe rather than 2 virtual machines, you probably should have all 10 up and running at that specific time. So auto scaling might not be for you at that point. It might be a scheduler in general in Azure. I mean, Azure has something called as automation where you could have 10 virtual machines to start at 9 o'clock for you and just leave it that way. It's not going to do any calculations or scaling for you. It just goes and powers them on. So there are other ways to deal with that problem. But remember that one hour for the auto scaling part. Okay. So let's go to the client machine and show you a little bit about that. So I'm here in my subscription and I'm going to go to my cloud service tab over here. Sorry, not over here. Then I'm going to click the cloud service and you can see there's a tab called the scale. Now that I came to the auto scaling over here, I just want to show you over here that everything is disabled. And can anyone just pause the screen right now and tell me, or just guess, not tell me, that why this thing is disabled? I'm assuming you have done so. I'll tell you why everything is disabled. Look at this error over here. Before autoscale configuration can begin, make sure that all the virtual machines in the availability set are of the same size. The only thing we have taken care of this cloud service is that we do have an availability set with 7 instances, but not all the virtual machines are of the same size. And if you remember the slides, I told you that they all need to be on the same size. The instance sizes need to be same. Others, Azure just can't calculate who is doing what. So if you go to see Ranger 001 and remember, we actually were demonstrating that scaling up and down, and that time from A2, I jumped to A3. All my other virtual machines over here are A2, but my C Ranger 001 during the demonstration, we jumped it to A3 and the resources changed. So we actually ended up scaling up rather than doing anything else. And the whole scaling does not support them. So I left it that way just to show you that all these instance sizes need to be of the same size before you can do auto scaling. So once that's done, if you come to the cloud services, you will see under the scaling that you will have the scaling options. And I'm not going to go through everything, but I'll show you what will happen here. You can scale based on different matrices and and of course a schedule. So you can set up a schedule and say that, hey, I want all these virtual machines to be up and running in this availability set at morning 8:30 or 8 o'clock because I know by 9 o'clock my employees are going to get in or my clients are going to get in or my customers are going to get on the website, for example. I'm giving an example of websites here because that makes the most sense, but there might be other reasons. It could be an app server, it could be a database server. And once again, you have to make sure the high availability is configured by you because Microsoft is not going to do that. So those still remain the limitations on the capabilities of high availability set that you will still have to maintain. However, what will happen over here is that if you have web services with the schedule, what it will do is it will actually make sure that at a certain schedule, the scaling is taken into consideration and the scaling is done for you. And the other metrics, as you can see, it's enabled now. So if you click on schedule, you can see that you can have this scheduling capability of scaling this. Okay. The other thing you can have, like I talked about, is like the CPU and the queue, things like those. So if you go to CPU here, you can show that, hey, uh, for my instance size, my target CPU is going to be that have, let's see, and these are sliders, by the way. So I can say that they have this 2 running. My target CPU is like from 60 to 80%, scale up by, oh, I don't know, scale up by another 5. So you can set all this information based on your business requirements and find out that how can you scale up. So in this point, I'm saying that scale ranges, I'm going to have two of them or three instances, target CPUs between 60 to 80. I'm going to make sure that you scale up by 5. Scale up wait time. You can actually have a wait time before the last scaling is done. So Microsoft does give you some capability of, throttling. The right term would be throttling this scaling up and down over here. But still, it takes up to an hour total for Microsoft to go and spin up and scale, scale it up for you based on our slides and what we have talked about. And the scale downtime, it is that, hey, if you go and find that all the instances between are no longer between 60 to 80%, what you want to do is that you want to start scaling down. You want to start turning virtual machines off. So you can say Azure that, okay, even if this goes below 60%, I want you to at least wait 20 minutes just to make sure that before you scale down, that you are not doing this prematurely. And you can go as low as 5. I would rather have more than less. So at this point, I'm doing this. And with the instance scalability, the other thing you have to remember is that when you have a scaling, like for example, 3 of them over here, what I'm telling it that is that with the CPU, all these instance sizes need to be between 60 to 80%, for example, okay? So it's not like one of these instances will be between 60 to 80% and you want to fire new virtual machines up. You want to make sure that all the 3 instances that you started with actually are between 60 to 80% before you start up new ones. So let's go through an example. So I'm going to set my minimum over here. So I'm going to say that let's start with 2 virtual machines and go all the way up to 7, okay? Because I'm going to use all 7 I have. So basically you start with 2 and 7. And I'm telling that if these 2 virtual machines consistently go between, I don't know, 50 to 75% maybe, yeah, 75% will be fine. So what I'm saying is that if 2 of these instance sizes are always having the CPU utilization between 50 to 75%, then start scaling up. And when you are scaling up, scale, I don't know, 2 at a time. Okay, so 2 of my virtual machines have to have consistently 50 to 75% of CPU utilization. And if you find that, start 2 virtual machines at a time. So it will become 4 virtual machines. Now, in these 4 virtual machines, if you find at one point it is all 4 of them are between 50 to 75, then I want you to scale up by another 2 till you have gone all the way up to 7. Maybe since I'm doing a factor of 2, maybe I should have made this 8. So it could have gone 2, 2, and 2, and 2, right? So, but I'm just showing this as an example. And once you have scaled this up, the very first time or each time, I want you to at least wait 5 minutes, even if they're saturated. So even if all my 4 virtual machines now are between 50 to 75% and they're still consistent like that, I want you to wait 5 minutes because who knows, maybe they will come down, right? So all those 4 instances at that point will have to be between 50 to 75 and wait 5 minutes before they're spun up all the way to 7 instances. And how are you going to scale down? Well, I'm going to say that scale down one at a time. And, when you scale down one at a time, I want you to wait at least 20 minutes between scaling down. And what it will do is that it will make sure that I'm not suddenly going down, which impacts my customers or clients. I'm going down gracefully till I'm back to the original 2 over here. So I'm not getting into too many details over here, and obviously this might be a little hard to demonstrate. The CPU spikes up and down, but do play with it, and this requires some sort of a planning. And let's get into the planning a little bit. The first planning you need to make sure is that you have those 7 virtual machines created in the same cloud service. You want to make sure all the 7 virtual machines or 8 virtual machines are part of the same availability set. Once they're in the availability set, if they're front-end servers, Azure actually provides you the load balancer, the one that we talked about in a previous session. So you could put them in the load balancer and Azure will load balance them for you. Okay. So if it was web front end, you'd be good to go. And you'd come over here and plan this out based on your requirements, either CPU or queues or memory or, I don't know, specific time of the day. You do that as well. So those are the things you'll have to plan. And the only point where I feel that this will be a little complicated is when it's not a web server. So you're not using the Azure's load balancer. For example, it's your database server, or if it's your app server. You might have to tackle that configuration by yourself, okay? If it's SharePoint app server, I know that SharePoint app servers talk to each other automatically. So as long as you bring up a new app server, it's up and running, they can talk to each other and the load balancing is done by themselves. But that might not be same for a custom web application that you might have created and they cannot scale up and down even if you create more virtual machines, okay? But that is the preferred way. This is the preferred way how Microsoft talks about scaling, or this is what elasticity is, right? I mean, you can pull it and or you can shrink it and you can make it go up and down, and this thing automatically will be handled by you by Azure. That's why it's called auto scaling. Okay, and Microsoft kind of prefers you do this for at least the services you can take care of. Anyways, guys, I think that brings us to our end of our session today. So we talked about high availability set, we talked about scaling up and down where we change instance sizes, and we talked about scaling in and out, which is auto, and that's handled for you by Azure. Okay, so it's important for your production as well. It's important for your uh, exam purposes as well. Anyway, so end of our session now. Our training site is, as usual, cloudranger.net/Azure training. We are at YouTube. This is where you're most likely viewing everything right now, Cloud Ranger Network. Twitter is at Cloud Ranger Blog. And of course, you can always email me at Sean@cloudranger.net. Okay? All right, guys. This was kind of short than my usual sessions, and I'm trying to keep them as short as possible. Let me know, provide me some feedback on if this works, or if I know I'm trying to speak a little more rapidly than I usually do to actually shrink them and not make them really long 1 hour sessions. Okay, so thank you for viewing, and I will be seeing you in our next session.